Okay, guys. So I am very excited because this should be the last video that I am making for this little stretch here. We should be back in class as normal on Wednesday. So I'm excited about that. Now, if you have not already done the November 16th check-in, I need you to go and do that now and then come back to the video. It's attached to the post on Google Classroom. It's very short. It's 3 questions. I need you to do your own work because I'm trying to gauge how well everyone's doing while I've been out and we've been having to do videos. So that needs to be completed before we move on with the video. So if you need to do that, please go back to the Google Classroom page, do that, and then come check back in. Okay, so we're just gonna get right into lesson 2.10 here. So you guys should be accessing your lesson 2.10 notes on OneNote. And I want you guys right away, I want you to do a pause here. I want you to pause, and I want you to look at problem number 1 and pick out which equation fits the description for number 1, and then explain what's different and what the other 2 equations would mean. Okay, so if you're back from a pause, it says Jada has $20 to spend. Games cost $1. Rides are $2. Which equation represents a relationship between the number of games, which we're going to use for X? So X is games and Y is rides. Those are the variables we're going to use. So the other thing that we need to make sure is games costing $1 a piece. So that's going to be related to the X for games. And rides costing $2 are going to be related to Y. So naturally, right, all of our equations have $20 total, which is good because she's spending the $20. And then we have a few slight differences here. But if we know that $1 should go with X and $2 should go with Y for the rides, our natural choice is C, because it is 1 times every X plus 2 times every Y, which are the rides, is $20. So what could the other 2 mean? Well, A could represent a scenario where games are $1 each and rides are also $1 each because it's just a single X plus Y. So if you said something along those lines, that definitely makes sense. And then B could represent a scenario where games are the $2 each and rides are only $1. So there's just a little difference there, but we need to make sure that we're putting the correct numbers in front of the proper variables. Okay, so this lesson is all about connecting things to graphs. So connecting our equations to graphs. And we know that equations are visually represented by graphs. So what we're talking mostly about here are lines. Okay, so these equations here, it says here are 3 equations. Each represents a relationship between the number of games and the number of rides and the dollar amount that they're spending. Okay, so we're going to look at 2 equations. We're going to look at equation number 1 and we're going to look at equation number 3. And you can see the little bit difference, right? In equation number 1, it appears that there's $20 total being spent. In equation number 3, it's more $28. And there's a little difference here. We have an X and a Y. And in equation 3, we still have X, but it's a little different here with 4Y. So going back, right, building back to our warm-up about what this equation represented, we'll kind of see what the changes are there. All right, so we just want to wrap our heads around a couple things here. Hopefully, right, graphs are not something that's brand new. We've seen lines. Maybe we've even heard terms like slope. Maybe something like y-intercept. Could be any of those things. So we're going to try to figure out maybe what we know and maybe what's new. All right, so the first one we're going to focus on is x plus y equals 20. And the first question is, What is the number of rides a student could get on if they don't play any games? So remember, X is games. Think of the X games. That's an easy way to remember it. I don't even know if you guys know what the X games are, but they're a thing. It's like skateboarding and BMX biking and all these other things, and they were like a competition, like the Olympics, but for like skateboarding and biking. Okay, anyways, so think of X, remember X games, and then the rides are Y. Okay, so if you don't play any games, which means essentially what we're saying is that we take this equation, equals 20, and we don't play any games. So we plug in 0 for X plus Y equals 20. So it looks like, oh, well, wait a minute. Yeah, okay. I mean, if they both cost $1, then we could play 20 games. So we say, oh, okay, great. So it says mark that point and label its coordinates. So we're going to go over here to the number. Look at our axes here. We have the rides along the Y, games along the X. So if we play no games, which means we're going to be here on the X-axis, but now we need to go up till we could ride 20 rides. So there's going to be a point right there, 0, 20. Remember, we always write our points as X, Y. 0 games, 20 rides. Okay, number 2 says, what's the number of games they could play if they don't do any rides? So it's the same idea. X plus Y equals 20. No rides. So X plus 0 equals 20, which is just X equals 20. So once again, since they're $1 each, if you don't go on any rides, well, you could play 20 games. So this point down here is 20, 0, because it's X, Y. 20 games, no rides. All right, this will be a little bit tricky for you guys, but it says draw a line to connect the points. I have a ruler function here, so I'm going to use it because then we'll guarantee that we make a straight line. And actually, you know what? Back that up half a second here. Oh, I'm going to get it perfectly. No. Okay, that's very good. Okay, so there's our line. So now we have a graph, right? We can graph lines. I mean, there's a couple things that we talked about. Maybe we've heard the idea of slope, maybe y-intercept. Let's see what we know. So it says, number 4 says complete the sentences. So now we're kind of focusing on the graph here. If the student played no games, they can get on blank rides. Well, we've already established if we look at our graph and we go over here to 0 games and we follow up, we'll hit right there at 20. So they can get on 20 rides for every additional game a student plays. So imagine that now we want to play 1 game. So 1 is going to be here. That's how many rides we could ride. What if we wanted to play 2? That's how many rides we could ride. If we wanted to go all the way to 8, this is how many rides we could ride, right? Because the solutions have to be on the graph. So it says for every additional game that the student plays, the possible number of rides, does it increase or decrease, and by how much? Well, as we play more games, look, as your games get bigger, what's happening to your rides? They're absolutely decreasing. And the question is by how much? So if you play more games, you can't go on as many rides. And look, if you play 1 game, it looks like you can go on 19 rides. So that's 1 less. If you play 2 games, looks like you can go on 18 rides. So that's another 1 less. If you play 3 games, looks like 17. So we seem like we're losing 1 every time. So it decreases by 1. Okay? Guys, you know when you read a graph left to right, if it goes down, this has negative slope. Think about it, right? Reading a book left to right, you guys are kind of sliding down the hill. So naturally the slope, which is just how steep the line is negative. So it asks, what is the slope of your graph? Well, remember that slope is always, it's as you move over, as you go over, how much do you have to go down? Over and down, each step, each step, each step. And it looks like what we're doing is as we go over 1, we are also going, as we go over 1, we are going down 1. So the slope of our graph, the slope of our graph is we decrease by 1 as we go over by 1. So we decrease by 1 as we go over by 1. And it says, where does the graph intersect the vertical axis, right? Vertical axis is our y-axis going straight up and down, and it happens right here at 0, 20. Now it's asking us to rearrange our equation to solve for y. Okay, so we can do that. X plus y equals 20. If we want to solve for y, right, we need to get y by itself, solve for y, get y by itself. So let's subtract x. So we're going to get y equals 20 minus x. Or we can write it as y equals negative x plus 20. Either way. And what we should notice here, right, is that, well, this 20 comes up. Oh, yeah, this 20 comes up as our y-intercept. It's like kind of like our starting value. And this negative here comes up in our negative slope. And it's also this decreasing by 1. So this shows that we are decreasing by 1 every time we play another game and we increase our x value. Okay, so hopefully that brought up some reminders there. So let's look at our second equation. We're actually going to go to equation 3. So x plus 4y equals 28. So here, let me do blue. X plus 4y equals 28. And we're going to go through the same process. Okay, so we can probably pick it up a little bit here. So if we went on 0 rides, that would mean, what's the number of rides if we played 0 games? So 0 games plus 4y equals 28. That means 4y equals 28. Divide both sides by 4 to find y is 7. Okay, so the number of rides, we're here at 7. Now, what if we didn't go on any rides? So x plus 4 times 0 rides equals 28. X equals 28. Pretty straightforward. So we're over here. So this is at 0, 7. And this is at 28, 0, because we're always x, y. Okay, let's get my ruler out here. Okay, that's pretty good. All right, so we drew the line. If the student played no games, so we're over here at no games, then they can get on, well, we found they could get on 7 rides. And for every additional game a student plays, the possible number of rides, it definitely decreases. We should know that, right? Because as we read left to right, this has negative slope because it's going down, right? You're sliding down the hill. And it decreases by how much? That's a good question. I mean, if we really zoom in on it here, look. So as I play 1 game, it didn't really move that much. As I play 2, didn't really move that much either. As I play 3, and look what happens here as I play 4. So it's kind of, as you play 4 games, it decreases by 1. So that means if we play 1 game, it'll only be a fourth of that. So it decreases by 1/4, right? Or we can think as we play 4 games, we can do 1 less ride. Okay. Or as we play 1 game, we can go on a quarter, but it doesn't make too much sense to ride a quarter of a ride. So it says, what is your slope? So again, we got to think. Our slope is we decrease by 4. Sorry, we decrease by 1 as we, what did I say? As we move over by 4. So this should tell us, and again, if you know this, that's great. If not, we'll build on it, but decrease would be negative. We decrease by 1 as we move over 4. So our slope is negative 1/4. And it says, where does the graph cross the vertical axis? Well, we know. It's at 7. We already found that. So same thing, we'll solve for y. So we're going to have x plus 4y equals 28. We need to minus x. So we get 4y equals 28 minus x. And we got to divide every piece by 4. So y equals 28 divided by 4 is 7 minus x over 4. Or you can write this as put a 1 in front and you can say 7 minus 1/4 x. Once again, the 7 comes up as our y-intercept. And here we see the negative 1/4 talks about decreasing by 1 as we go over by 4. So it's just how much do we have to go down and over each time to kind of get to the next point that's on the graph. Okay, so here's a very, very similar problem just about nickels and dimes. So it says Andre's coin jar contains 85 cents. It's all nickels, all dimes, or some of each. So write an equation that relates the number of nickels and dimes and the amount of money. Well, we can definitely do that. So we know that a nickel is 5 cents, so 0.05 N plus 0.1 D equals 85 cents, 0.85. Now, if you notice here, guys, look at all of our numbers. This might be a lot easier to maybe deal with if they were nice whole numbers. So what if we multiplied the whole thing times 100? That way we could just make this 5N plus 10D equals 85. Maybe, if you're comfortable with decimals, that's fine. But maybe we'd like to times it by 100 and make them all whole numbers. Okay, so number 2 says to graph our equation. But here's the thing, how are we going to know how to graph? Well, what was our strategy? We said, let's find the point where there's none of one, and then the point where there's none of the other. So let's take the case where we have no nickels. So we'll split this. So we have 5 times 0 nickels plus 10D equals 85. So there's nothing there, so 10D equals 85. Divide by 10 to solve is going to be 8.5. So let's make our nickels down here and our dimes on the y. So we have 0 nickels and 8.5 dimes. So there's our point, 0, 8.5. And then in the other case, we have 0 dimes. So that's nothing. 5n equals 85. Divide both sides by 5, right, to undo that multiplication. So 85 divided by 5 is 17. So there should be 17 nickels, 0 dimes. So this is 17, 0. Okay, and then we can draw a line between the two. And there's our graph. Okay, so now it says how many nickels are in the jar if there are no dimes? Well, we know that point. That's the point right down here. Nickels with no dimes. So there would be 17 nickels, 0 dimes. And then it says how many dimes are in the jar if there are no nickels? Well, here we have that point. It's 8.5. Well, but I mean, granted, that's what the equation told us, but there's no such thing as half a dime. So number 4 is not possible because there's no half dimes, right? I mean, there is, like, there's nickels, but here, the better way to write it was not possible because 85 cents can't be all dimes, right? Dimes are just going to have multiples of 10. So 85 is not going to cut it. Okay, so the last thing here, this is our cool down here. Karan is spending $12 on games and rides at a carnival, and games are 25 cents and rides are $1 each. So write an equation to represent the dollar amount Karan is spending and the number of games and rides he could do. Okay, so remember, games is X games, rides is Y. So we're going to have 0.5 25x, because it's 25 cents per game, plus y equals 12. So the question is, which graph is going to represent this? Well, we're looking for something where they all equal 12. So there's 12 to start, 12 to start, 12 to start. And the question is, as we play more games, right? Read your graphs left to right. As we play more games, what's going to happen to our ability to ride rides? Well, if we're playing more games, it means we're spending more of that money on games and we have less money to spend on rides. So A is not going to work because what we should notice is that this is positive slope. This is saying if we play more games, then we'll go on more rides, but that's not true. We were only given $12 to spend. So now we're trying to come down between B and C. And I think a really easy way to find this is to test this point. Look at what this is telling us. This says if you play 3 games, you will have no more money to go on rides. You will not be able to go on rides. And do we really even need to test this? I mean, think about it. If we were to plug in 3 here, that's 75 cents. We should be able to go on a bunch of rides. We'd have tons of money left over. So that's no good. So it looks like our option here is C because it has negative slope. And it kind of looks like, right, as we play a few games, maybe like 10 games, we can go on a couple less rides because games are only a quarter. And maybe way over here, as we play like 40 games, maybe then if the line kept going, right, maybe then we wouldn't be able to go on rides. So yeah, so we just got to use some process of elimination here. Okay, so hopefully not too much of that was brand new, but maybe we just brought a couple things back. So you guys can get started on 2.10 homework, a couple things about graphs, about the equations, and we're trying to create that connection between those two. So it's assigned in Teams in OneNote. It's due on Wednesday. Super excited. I will see you guys in the Zoom on Wednesday. Talk to you guys then.